will look or examine. I will use real world examples to create an understanding on what DNS security is and what are the three flavors available, right? Broadly speaking, there are three flavors available in terms of DNS security. One is Dnsec, the security extension of DNS. And the second is DO, which is DNS over HTTPS. And the third one is DNS over TLS. Now, the use cases of all these three are different. All of them provide security to DNS, but in different ways. Now, we'll examine that with real world examples. And I'm not going to start with a table which says what is what and definitions, because that we have that in Aloha readily available, but that doesn't make sense. And these need real world examples to paint a picture or to get a clear understanding. So let's look at what DNSSEC does. Okay, it's not exactly DNS security, but it's DNS security extension system, as they call it. Now, it comes with HDNS product. Now, what does it do? It secures the DNS answers by signing them cryptographically. So now let's take an example, a very popular example of this protein powder, which is normally used and which is faked a lot. So how do we ensure that the product that you have received is a genuine one and not a fake one, right? So you take the hologram and you probably go into their website and put the hologram or QR code or whatever the code is, and it will, and message will pop up saying, hey, this product is genuine, right? So that's how you do for the protein powder or any product for that matter, right? That's what DNSSEC does. So what DNSSEC does, once you have a zone or a, say for example, akamai.com on HDNS, so what we do is we take all the A records, we bundle it together. We take all the CNAME records, we tie it together. We take all the IPv6 records, we tie it together. We create bundles and then sign it, cryptographically sign it using a key. Okay. Now, when somebody queries for an answer, we don't just give out the answer, but rather along with the answer, we give out that encrypted version of it. For example, I've shown in the slide, when we make a query for www.akamai.com, of course, we return the CNAME, but along with the CNAME, we give out an RR-SIG record, or to be specific, whatever we bundled and signed, right, that one we will give to the resolver or the client. Now, what the client will do, imagine it has got a protein shake, and this particular whatever the encrypted version, it's called an RR-SIG record, right, or resource record signed one, right? So imagine that as a hologram RR-SIG record, and imagine the CNAME as the product. Okay, so now what the resolver does is the resolver will see, okay, I need to decrypt this RR-SIG, okay, and match it with the hash value of the CNAME. If the hash value matches, then I've got a genuine product. Similar to how you go to a website and say that put in the hologram or QR code, whatever, and measure the genuineness of the product the same way, right? So that's how DNSSEC does. If you noticed, we are not encrypting the pipe. We are not encrypting the transaction itself, but we are putting a hologram on that particular record, which the resolver can leverage to verify the authenticity of the record that it got. Now comes the question, how does it, decrypt it? It needs a key, right? The key which we use to encrypt the record in the first place, that is called as a DS record, right? So that is the key. So the resolver now goes and fetches the key and decrypts, matches the hash value and says that I got a genuine record, right? Now, where do we keep the key? If we keep the key with you itself, then it's useless. You're locking your home, you're locking your car, and you're keeping the key in the car itself. That's absurd, right? So that's where what we call the chain of trust is. We keep the key. The key is not secret. So I've heard customers who are like, don't share the DS record key over an email. It's meant to be public, right? It's okay if you share it in an email because it's meant to be public. But the placement is what matters. You place the key one level above. For example, if you're encrypting akamai.com, you place it at the TLD or the upper domain, which is the .com server, right? If it's www.akamai.com, you place the DS record on akamai.com. In the same way, you build a chain of trust. You encrypt akamai.com and place in .com, and you encrypt the .com and place it at the root zone. Now, what will happen to the root zone? Where will you place it? Because there is no other level. That's where the manual component comes in. But this is how the chain of trust is built in DNSSec. Essentially, ISP resolvers or even client for that matter will get both the raw or the actual answer and the encrypted ones. So the resolver will go out and fetch the key from the parent zone and then look at the authenticity of that product or that answer that it got. So it's not exactly encrypting the pipe like HTTPS, but it's actually verifying the authenticity, which is what the DNSSec does. Now, quickly moving on. What is DOT, DOH? Imagine an Amazon package, right? That's exactly what DOT or DOH does, or in simple terms, here we are encrypting the pipe. We are encrypting the traffic. The same way how we do it in HTTPS, which is actually DOH. I've given a sample there as well, which is a post query. I'm not going to go into the details, but DOH is necessarily a 443 port request where DNS queries are done over an HTTPS pipe. And of course, you can think of it like a package of Amazon, which is encrypted, which cannot be tampered with and all that. And DOT is nothing but DNS over TLS, which is at the layer 4, where DNS over HTTPS is at the layer 7. I've given you an example as well. So 3 different use cases, right? 3 different use cases. So when customer says Google does it, Google Resolver 8.8.8.8 does it. So what does he mean by that? What he means by that is Google's resolver or Cloudflare resolver is doing DOH or DOT, right? That's what he means, right? So 3 different use cases, as I said. Now, a few of public opinion on what DOT, DOH does. And the prevalent opinion as well as my opinion is DOH, even though many browsers, for example, Mozilla is pushing for it, we scientists and including me are not a big fan of it, because when you move things to the layer 7, you're opening Pandora's box for a large volume of attacks, different kinds of attacks because of HTTP layer, WAF and everything. So you're literally opening Pandora's box. Of course, DOT to an extent avoids all that problem since it's at layer 4, but then again, the certificate and there's performance implications and all that. But if you ask me, personal opinion, DOT is a better candidate than DOH. Of course, both are popular, but yeah. Now, here's a table for you to refer. The ports, the definitions, what is a suitable product for DOT, DOH, and DNSSec, everything I've given there. DNSSec, as I said, it's encrypting the zone file, right? So that's why when we talk about zone file, it's HDNS. It's an HDNS feature. But when we talk about DOT or DOH, it's encrypting. We are talking in terms of resolver. Resolver will talk to the another resolver, encrypt the pipe and everything, right? So we are talking about ETP and AnswerX there, right? AnswerX is also a resolver service that we have. So if anybody wants to secure their Yahoo, Google domains as well, then ETP is the product for them. And one key thing to remember here, the third row, that DOT and DOH is not end to end. It's only from client to resolver. To give you an example, from client to 8.8.8.8, not all the way until the authoritative name server, right? That exists for DNSSEC, but not for DOT or DOH. Of course, we cannot compare because these are different flavors altogether. Then comes a big question. Don't we have end-to-end encryption for DNS then? If you say DOT and DOH are only till a resolver, isn't there a protocol for end-to-end encryption? That's a very valid question. And we introducing ADOT. ADOT is an upcoming spec, which is authoritative DNS over TLS, which addresses this problem between the resolver and the authoritative name server. It's still in draft stages. So you can go and Google it and take a look at the RFCs. But yeah, it's a good read. It's a really good read. All right, that's it I had for today. For any interesting discussions, please, you can liaise with me on Teams or even on LinkedIn, or even you can use the Q&A portal to ask any questions.